All right, so we're going to focus on 226 today. And so how we're going to do that is, let's first read the question. Determine the magnitude and direction of theta of force of A so that the resultant force is directed along the positive x-axis and has a magnitude of 1250 newtons. So what we're going to do, well, first, so step, there's practically like 4 steps in this problem, and we'll go step by step. But the first step is to resolve the resultant force of A into its x and y, you know. So we'll start out with that. So if we know there's the x component, there's also the y component. We'll start out with the x component. If we do the force of A at x, that's equal to the resultant force of FA. But to get it to its x-axis, well, you see this theta right here, we'll be working with that. So do you see a kind of triangle with that? That's what we're working with. So I'll redraw it down here. And we make a right angle triangle. Theta's right here. And this is our force resultant for A. This is FA. This is our X. And then this is our Y. So if we base it off of that, to get our X, we need to do some geometry. That means is to find X and f of A. It may look confusing at first because you're like, man, I don't know what these numbers are. Well, just stick with it for now, and it'll make sense later. That's sometimes throughout the statics course, that's kind of what you have to do, is kind of step into the unknown and hope it'll resolve itself out later. So, but obviously we can see that this theta and this x, this is opposite. This is the opposite side. So if we're looking at the opposite side and its hypotenuse, we're looking at the sine of theta. So sine of theta, that'll give us our x. And for our y, its adjacent side and the hypotenuse, which will be cosine. So we have that. That's for A. Now for our B, we got to break that up as well. Now, do you see that the B also has a triangle? If we can create the triangle right there, that's the right angle. So if we recreate that triangle down here, sorry for my artistic skills, that's 30 degrees. That's a right angle. This is our X. This is our Y. This is our FB. Now it gives us our 800 newtons. So we know what FB is, but we don't know what these two are. And we can solve for that because we resolved it into the triangle. Now using the SOHCAHTOA again, for our X, its adjacent side, and we know what that hypotenuse, and we know the angle. So we're gonna go cosine this time. So if we replace 800 for this, plug that in, we get 692.82 newtons in this case. Notice how for the last x, we use sine, and for this one, we use cosine. So just because you sometimes see x go with sine or x go with cosine does not mean it'll always stay that way. It might switch for different times in this case. So if we go with our y now, fby, that's equal to fb. And now we're looking at the opposite and the hypotenuse. So by the SOHCAHTOA, we're looking at the sine of 30. And replacing this again, FB with 800. So 800 times sine of 30. That'll give us 400 newtons. Now, something to realize is that we understand this is if this is our like positive, if we know what our positive axes are, so obviously in the y, we're going to stay normally upwards for y is positive, and for right, x is positive. What we notice is this b is down and to the right. Now it's right and x is positive, but its y is negative. So what we have to do is we have to say it's not just 400, but it is negative 400, if that makes sense. Because we're going to the right, which means a positive x, but we're also going down, which is a negative y. This is fine because we're going up and to the right, or right and then up, still achieving that positive, you know, force. So no matter how you look at it, you're always going positive. Okay. So the next step is we need to find the resultant force. Now, what I mean by the resultant force is now we know what we've resolved it into its simple components. And now we can look at the resultant force of x. So resultant force, I'm just going to claim as r, and then the x for the x direction. That's equal to fax plus fbx. The only two x components that we know of. And so we'll just add them together. But obviously we don't know what fa is or sine of theta is, really. All we know is from the problem statement, the resultant force in that x direction is 1250 newtons. So what we can do down here is we can replace our Rx with that 1250 and our FAX, FA sine of theta plus that 692.82 newtons. This is from the problem state. This is from the problem statement. This is from what we've resolved. And then this is from what we solved up here. Okay. Next up, let's get all our knowns on one side and all our unknowns on the other side. So what we'll do is we're going to take this 692 and we're going to subtract it from our 1250. So FA sine of theta is equal to 1250 minus 692. That'll get us 557.17. I'm going to round up and say 8 Yes. So now I'm gonna do the same thing with the y, resultant y component, FAY plus FBY. If we go back up, we look at the problem statement again. It says that the resultant force is directed along the positive x-axis with a magnitude of 1250 newtons. So what that means is the resultant force, which means there should be no forces acting in the y at the end. So what this will mean is this is 0. So that means 0 will equal FA cosine of theta minus that 400 we got earlier from up here. So now we get FA cosine of theta, which is equal to 400 newtons. Now it seems like I have, this is an unknown, this is an unknown. We have two equations and two unknowns. Now, when it comes to systems of equations, if I have two equations and two unknowns, because the numbers match here, that means there is a solution that we can find. If this was two equations and three unknowns, then it would be unsolvable. If it was two equations, one unknown, it would be solvable. So, because we know it is solvable, because we have two equations, two unknowns, all we got to do is either one, solve for FA and solve for FA up here, and then plug it into the equation down here, or solve for theta and plug it in down there as well. Like so. So, well, I'm just going to go with solve for FA first because it looks, I don't know, less stressful. So I'm going to border that off. How I'm going to do that is I'm going to solve for FA. I'm going to solve for FA down here. What I mean by that is I'm going to take FA is equal to 400 divided by cosine of theta. Plug that into our equation over there. So it's going to be 400 divided by cosine of theta times our sine theta, which is equal to 557.18. Now this gets us our 400 times our sine over cosine, which is just tangent of theta, which is equal to 557. Divide 557 by 400, and then take the inverse tangent to that. So it'll look like this. We should come out with a if you did it right, then you should have gotten 54.32, 32 degrees. So that's how we solve for our theta, is because that's what I meant by earlier when it doesn't make sense. but you just keep going through the problem and then it'll sort itself out because at the end you have those two equations and two unknowns. All right, now we get to solve for FA, which will be the easy part because we already solved for theta. So we'll just take one of the equations, FA cosine of theta equals 400. Because we know theta now, which is that 54.32 degrees, we'll divide the 400 by cosine of 54. So it'll look like this. Cosine of 54.32. And then that'll come out to be 685.08 newtons. There we go. So that's our magnitude that we just solved. And then this is the direction, 54.32 degrees. So we solved for magnitude and direction of FA.